I'm Becca.
Mi nombre es Pablo.
My name's Sam.
Thanks for watching us on DPS TV. Hi, today we are going to be working with what's called systems of equations. Cut to my screen and I'll show you what it is and explain a little bit better. Systems of equations are basically a set of equations with that number of variables, or they have the same variables and they can be solved together. So sometimes you might run into a situation where you have two variables. You can't really solve that equation unless you have another equation with it. So I'm going to today I'll show an example of linear equations, and I will also get into the equal values method to solve. There are a couple ways to solve these. And in other videos later on, I'll get into substitution and elimination, a couple other ways to solve these types of equations. So here is just an example of a situation that you could use systems of equations to solve. In fact, this was one of my favorite topics in math growing up because in my mind it was the thing that I could actually use the most in real life is, well, what happens if there are two things that are unknown? And how do we solve? So I really like this one because it really applies to a lot of stuff. So here's an example. This is coming from the CPM curriculum that Denver Public Schools uses. It's coming from their Integrated 1 textbook. And the example says, as Sally and George practice for the SAT, their scores, and actually, you know what? While I'm reading this, I'm going to highlight what's important. So as Sally and George practice for the SAT, their scores on practice tests rise. Sally's current score is 850. Sounds like that would be important. And it's rising by 10 points per week. Also important. On the other hand, George's current score is 570 and is growing by 50 points per week. The question asks, when will George's score catch up to Sally's? And part B asks, if the SAT test is in 12 weeks, who will score the highest? So I really like this part here because systems of equations can really, what they can do is they can tell you when two things are going to be the same. Like for another example, I used this myself earlier on in my life when I was trying to figure out which cell phone plan to go with. Is if I pay this much, start with my baseline and I pay this much per month, or if I start with this and pay this much per month, which is going to be better over time, or when would they be the same? This is just an example of where you could use it. So in terms of this problem, let's first, before we actually go to the algebra portion of it, let's look at this in a table. And then we'll also look at it in a graph. Because these are two ways that we could possibly solve this if we didn't know the algebra to do so. So back to the actual question, it said that Sally's score started off at 850. So we would say maybe at week 0, her score is 850, so she's starting there. So that's why we say week 0. She's rising by 10 points per week. So each week that passes, her score is going to go up by 10. So we can go ahead and fill in the rest of her chart. So 860 on week 1, 870 week 2, 880 week 3, 890 on week 4, and so on. I'll just fill this in real quick. All I'm doing is adding 10 each time to get to what her score will end up being by the end of week 12, because we also wanted to know that information. Okay, so we got all the way up to week 12, so it looks like at week 12 she is going to have a score of 970. Now for George. George's current score is 570, which is a lot lower to start with than Sally's score. However, he is growing by 50 points per week. So he's growing a little faster than she is, so you can probably guess he'll probably eventually catch up to her. So his next score is going to be 620, 670, 720, and again, all I'm doing here is adding 50 each time. $870, and I'm going to go up to week 12 again. And you can kind of see here, even at week 6, he's starting to catch up to her. And look what happens in week 7. and he goes all the way up to 1170. And that's really what I want to highlight here is week 7 is where their scores are the same. So we don't necessarily need algebra for this particular equation, or sorry, this particular situation. But what if it didn't work out exactly this way? What if he was gaining 40 points every week and he caught up with her maybe somewhere in between week 6 and 7? So this happened to be nice numbers, but this would be our solution to the system of equations, is in week 7, their scores would end up being the same at 920. Graphing this, we could do, I'm going to do Sally's we'll do Sally's in blue, and I want to show you what this looks like here whenever we find the solution. So Sally's in blue, she starts out on week 0 at 850. She goes 860, so she's not growing very much every week, but she is growing. Week 2, week 3, I'm just estimating here where she is. In fact, here's what I'm going to do is I'm just going to plot her nice numbers. So 850, 900, 950, and we can just connect that because we can see that it's linear growth. So on week 10, she was 950, and so on. So let's just draw a line here, a blue line for Sally, and she's growing like this. All right, and then we said George's score, so he's growing by 50 each time. He starts at 570, so we'd put that maybe right about here. And then by week, let's see, we'll do week 4, just so we don't have to plot it all. Again, it's linear, so we'll do week 4 is right about there. Maybe I should do this in a different color. We'll do it in green. Week 4, we'll do week 8. So week 8, he was 970. So we got him right about there. And you can see he is passing her really quick. So we're going to go ahead and connect his line. We've got to make it green. You can see he's growing like this. And some of my dots are not very accurate here. So let's double check this week 4. 770, that's why. Sorry about that. He should be more like right here. All right, and then this point here, let me highlight it in another color so that you can see what I'm referring to. This point right here, this is where they're the same. And you can follow it down even to the graph and see that on week 7, it's the same. And it's hard to tell exactly because of my scale, but you can see that it's somewhere in between 900 and 950 if we followed it over, which it was 920. So systems of equations, this situation you could solve with a table, you could solve with a graph. And this is what our solution looks like in a table and in a graph. However, we can also solve them algebraically. And that's what I'm going to get to today, is the equal values method. So what we want to do is we want to write an equation for each person or each situation, and then we're going to solve them. So let's say Sally. We're going to do Sally first. We're going to call Y our score, and we're going to call X our week number. And we can write an equation. We can say to find the score, we would take, and we'll look at her rate. So it's 10 points per week. And I'm not going to explain too much how we come up with this equation. We can talk in other episodes how to write equations. But it would be 10x plus what she started with, which was 850. So an equation that would represent her score would be this: y equals 10x plus 850. George would have a slightly different equation, but again, we're using the same set of variables, which is why we can use the systems of equations. So we're going to say to find his score, or y, let's look at his rate. He's going up by 50 points per week. So we'd say 50 times the number of weeks plus his starting score, which was 570. So the equal values method uses the idea that we're trying to find when they're both the same. So we know that we want this y, or the score, to be the same thing. And if both of these y's are the same value, then what we can do is we're saying that this represents Sally's score, this represents George's score, and we want them to be the same. So what we can do, very simply, is make them equal each other. I want to know when Sally's score, which is 10x plus 850, is equal to George's score, which is 50x plus 570. And if I can get that x by itself, which we know that that represents weeks, then I will know which week their scores are the same. So what we're going to do is just algebraically get our x by itself. We can subtract 10x from both sides to get our variables on the same side of the equation. So then I have 850 on the left, and on the right I have 40x plus 570. Then I'm going to subtract 570 from both sides, which I end up getting to, let's see, 250. Is my math right? I'm kidding. It's good, I think. 40x, just doing this in my head. And then lastly, we're going to divide by 40 to get our variable by itself. And we end up getting, and I'm not doing this math in my head, you should end up getting 7 equals x. Did I do that math? It was 280, I believe. Is it 280?
Yes.
Double check me. Okay, 280. So 280 divided by 40, and we get 7. And again, this x represented our number of weeks. So in 7 weeks, they'll be the same. Now, it's up to you which method you use. Honestly, once you know the algebraic method, a lot quicker to use this, to be completely honest. And another benefit to the algebraic method is that if this was not a nice whole number, then we could solve it algebraically and we wouldn't be able to see that same solution on the table. And as we saw here, it's hard to read where exactly that is on our graph. So you have to be really accurate to be able to do it on the graph. So what you just saw here is one of our methods to solving systems of equations. That was the equal values method to solving systems of equations. In a couple other videos, if you're interested, we will show you how to use substitution and also how to use elimination. A little bit more about systems of equations. We talked last week about one of the methods to solve. Today we're going to talk about the method of substitution for solving systems of equations. So if you go to my screen, in a previous video we talked about systems of equations and what they are. Systems of equations are when we have more than one variable, and so then we use more than one equation to help us solve for those multiple variables, more than one variable. Sorry about that. Last week we looked at equal values method, and that is if we had, for example, we had two equations that both were to equal the same thing. This is a common situation when we're solving systems of equations, is when are these two values the same? And we use the equal values method to solve. Today we're going to look at the substitution method of solving. So the second method, the substitution. Now, substitution works very well when we have an equation with either one of the variables already by itself or one of them that is very easy to get by itself, meaning not a lot of steps or not having to work with division and messy numbers. So this set of systems of equations works very well because in this first equation, we already have y alone. So that makes this a very good method to choose in terms of solving this systems. So we'll use this method. We'll use the idea that every time we see y, we could replace it, it's equal to 6x minus 11. So what I'm going to do is I'm going to go into this next equation and replace my y with 6x minus 11, since y and 6x minus 11 are equivalent. They're the same thing. So we're going to go and we're going to replace. So I still leave everything else the same. I have negative 2x minus 3. And then again, I'm replacing this y with 6x minus 11. Because again, that's what it equals. Equals negative 7. So what you should be noticing here is that now I have one equation with just one variable, x, and I can solve that. I just have to isolate x, get it by itself, which is a lot easier than dealing with two equations. So I'm going to follow my typical steps of solving linear equations. The first would be if I have any distribution, I want to do that. So that's going to end up giving me negative 18x plus 33. That negative times a negative would give me a positive, equals negative 77, or sorry, equals negative 7. Then we want to combine any like terms that we may have, so simplify by combining like terms. You may notice this negative 2x and negative 18x, those are like terms. So we're going to get negative 20x plus 33 equals negative 7. And then we're just going to do our moves to isolate this variable, get x by itself. So I'm going to subtract 33 from both sides. So that cancels. I end up with negative 20x on the left, and on the right I have negative 40. And then continuing to isolate this x, I'm going to divide both sides of my equation by negative 20. That cancels. I end up getting x is equal to 2. Now, one common mistake that I see students do a lot is I see them stop right here. This is only half of the problem. When we're finding a system or a solution to a systems of equations, I'll kind of go back to the one we talked about in a previous video. There is always, we're solving for two variables. Or in another way to think about it is we're trying to find where those lines would intersect. And when we find where it intersects, we always talk about that coordinate as an x and a y, not just an x or not just one value. So we're actually trying to solve for two variables here. So if we stop just at x, we're not finished yet. That's only half of it. We need to then use this answer or this solution to help us find y. So we found that x is 2. That means, just like we substituted to start with, that I can substitute any x that I see with 2. So you can choose either equation, doesn't really matter which one, to solve for y, but honestly, make your life easier. And here's why I say choose this one, because that y is already isolated. All you're going to have to do is simplifying. You won't have any extra solving to do. So over here, I'm going to go ahead and replace my x with 2, since we figured out that that's what that is. So I did y equals 6 times 2 minus 11. And then all we need to do here is simplify. We're just using PEMDAS to help us simplify. So we do multiplication first, and then our addition subtraction, which is going to give me y is equal to 1. Now again, when I talked about the solutions in the last problem, or in the last video that we did, we said that it could be an xy coordinate where they intersect. So what we're going to do is we're going to say that our solution would be at the coordinate where our x is 2 and our y is 1. So this would be our solution here. Now one last little thing is if you wanted to check your solution, what you would do is you would go back to your original equations and we would replace both our x and y. So we'd replace our y with 1 and our x with 2 in both equations and make sure that both sides of those equations are equal when we do that. So this is the substitution method. One more time, it's really great if you can get one of your variables alone, like that y, or you already have one of your variables alone. This is a great method to use. Hopefully this helped. Let us know if you have any questions, and there's substitution for you. We've already talked about two methods before, but this video is going to be about the elimination method of solving systems of equations. If you cut to my screen, I will brief really quick of what a systems of equations is. In algebra, a systems of equations is when we have two or more variables that we need to solve for, and so we use two or more equations to solve for those variables. We've already looked at two of the methods to solve the systems of equations, equal values method and substitution. We are today going to look at a third method called elimination. This method, I will tell you, when I was in high school, I did not appreciate enough. But once I got to learn math a lot more, I realized just how great this method is. So this method is really great when you have opposites, or when you notice in your two equations that they're opposites. What I mean by opposites, and I'll give you an example, is 2x and negative 2x. These are opposites of each other because they cancel each other out when added together, eliminate each other. So if you notice that there are opposites in your equation, or something that you could make into opposites, which I'll show you later, then this is a great method. If you were looking at the two equations that I have set up here and guessing, oh, that you see opposites, you are probably right. We have opposites right here, where we have a negative 4x and a positive 4x. Those would cancel each other out. So what we want to do when we are using the elimination method is, the first thing is create opposites. Now, if you already have opposites, then you don't need to do this step. And we already have opposites here. Again, I'll show you another problem in just a moment that doesn't have opposites already, but how you can create them. The second thing that we are going to do is we're going to combine our equations into one. So almost like a big giant addition problem we're going to do. So I'm going to take this negative 4x minus 2y equals negative 12, and I'm going to add 4x plus 8y equals negative 24. I'm going to add these things. One thing that you want to make sure is that you keep everything on your equal sign that's to the left of it, keep it to the left of it. Everything to the right, keep it to the right of it. Make sure that these are lined up when you do this. So the first thing I'm going to do is add negative 4x plus x. These are our opposites. They eliminate each other, hence why this method is called elimination. Then I'm going to add my negative 2y plus my 8y, which would give me a 6y, equals, and then I'll add what's on the other side of the equal sign. I have negative 12 plus negative 24. I get negative 36. Now we're left with a much simpler equation. 6y equals negative 36. This is going to enable us to solve for y pretty easily, so we just have to get it by itself. So we're going to divide both equations by 6, and we get y is equal to negative 6. I spoke in the earlier video on substitution about why we can't just stop here. This is a really common mistake. Students want to say, oh, I got the answer, I'm done. But for systems of equations, we are solving for two variables or more sometimes. And so we need to make sure that we solve for all of the variables in question. So we've already solved for y. We now need to solve for x. That means we're going to choose one of our equations. Doesn't matter which one. But choose one of our equations to substitute y into. I'm going to pick the first equation just because we're working with a little bit smaller numbers. Make your life easy by picking the easier equation, but it doesn't really matter. So I have negative 4x minus 2y, and now since I know my y, I'm not going to write y. I'm going to write negative 6, and I get negative 12. So then what I need to do is I just need to simplify and get my x by itself. So I'm going to do this multiplication first. Negative 2 times negative 6, we get positive 12. And just continuing to solve this, get it by itself. We're going to subtract 12 from both sides, and we end up getting negative 4x is equal to negative 24. And then we're going to divide both sides by negative 4, and we end up getting x is equal to positive 6. So I also discussed this in the last video on on substitution. Our answer is always a coordinate. What we're wondering when we're solving systems is, where do these lines intersect? So they will intersect where the x is at 6 and your y is at -6. So our solution is this. Now, I mentioned earlier that I was going to show you an example problem where we need to create opposites. So this, again, is a situation that works really well where you already have the opposites, but sometimes you just don't. So here's an example of an equation or a set of equations where we don't already have opposites. What you might notice is I've got a 5x and a 10x here. I could easily multiply this 5 by -2 to make it a -10, which would make this opposites. That's one option that we have. Another option we have is I have a positive y and a -7y. Another thing I could do is I could multiply this whole equation by 7, positive 7, and then I'd have positive 7y and -7y, and those would cancel. So you've got some choices here. I tend to say, make your life easy, choose what would be easiest for you. In terms of rules, all you really need to make sure that you do is if you do one thing to one side of the equation, you have to do it to the other. So what I'm going to do is, I think to me, what would be easiest is make this 5 into a -10, because I know that if I were to take it times 2, -2, that would do that very easily. So that means I got to multiply my whole equation by -2. So I'm going to go ahead and do that, distribute that -2 to my entire equation, and I end up getting -10x minus 2y is equal to -18. And so now the two equations that we're going to be working with are these. This equation on the bottom here is equivalent to the equation up top. Same thing. It's kind of like saying 1/2 and 2/4. They're equivalent. They're the same thing. We just multiplied everything by 2. Same deal. So you may also notice now, here are my opposites. I did that on purpose so that they could cancel. So we're going to add our two equations together, or combine those. My 10x plus my -10x, again, those cancel, they eliminate. My -7y plus -2y is going to give me -9y. And over here on the right, I have -18 plus -18, which gives me -36. Again, I have a much simpler equation now with just one variable. We're going to solve it by isolating that y. And we end up getting y is equal to 4. This is only half of our answer. So we're going to go and replace this into one of our equations. And again, be easy on yourself. I'm going to pick our original 5x plus y equals 9, because that is the simplest equation to me. And I'm going to say 5x plus 4 equals 9. So all I'm doing is just replacing that y with 4, and then subtracting 4 on both sides. So now we're getting x by itself. We get 5x is equal to 5. Divide both sides of our equation by 5, and we end up getting x is equal to 1. So then our our solution now is where x is equal to 1 and our y is equal to 4. So this is the solution to this systems of equations. So now you have 3 methods to be able to solve systems of equations. The hardest part at this point is deciding which method to use. Just to summarize really quickly, equal values method is really great whenever you have 2 equations that are equal to the same thing. For example, 2 equations where it's y equals blah, 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 and y equals blah, blah, blah. Substitution is really great when you can isolate one variable easily. Doesn't have to be in both equations, but this one is really great for that. And elimination is really great when you have opposites or can make opposites very easily. So those are 3 methods that you can use to solve, all equally valid methods, but I'm sure you will have your preference. And now you know how to solve all 3. Thanks for watching this episode of Tutor This. As always, if you have questions or suggestions for future episodes, leave them in the comments below. Remember to click the like button below, and if you enjoyed this video and want to see more like it, hit subscribe.